as we mentioned, there is no point in doing a force diagram on the surface here because the only forces are normal force and gravity, and they're equal, and that's fine, cancels out. But there is, of course, a point diagram here, right? So I do F sub n like this, and I have F sub g here, and of course I have to crack that. So here I have Fg sine theta, and here we have Fg cos theta. So we know the sum of the forces in the x direction, and I'm saying x meaning parallel to the surface, that's ma. And so the only thing is mg sine theta. Now, here it depends on how you're defining velocity acceleration. Obviously the going up the right. So if that's true and that's positive, then I have to say that this is negative. Does that make sense? Like Fg has to be a negative. So then I get ma here, and that sort of makes sense because then a is negative. Does it make sense? Does it make sense? Acceleration up incline is negative. Why? What is this box going to do? It's going to stop at some point, right? So there must be an acceleration down the incline, and that's just from gravity. Then I don't really, there's no friction, so I don't need to worry about the y direction. So my a is negative g sine theta. So I know my initial velocity is v. I know my final velocity. I know my initial velocity. My final velocity is going to be 0, and I just want to find d. D is my distance up. Now, how does h relate to d? H is d sine theta. I'm looking for d. That's going to be h over sine theta. So I can plug that in down here. Well, I can put all this stuff together in an equation that works. So v squared is equal to v0 squared plus 2ax. And in this case, instead of x, I'm going to use so then I have v squared equals v0 plus 2ad, and d is actually h theta. So we know that v0 squared, we know that v0 squared is v, we know v final, right? So we've got v squared is equal to negative 2ah over sine theta, right? So we can get rid of that and take the square root of that. And of course, our a was negative g sine theta. And since a is negative g sine theta, I can plug that into this a here. I get v0 is equal to the square root of negative 2 times negative g sine theta h over sine theta. So the negatives cancel, sine, and I get v0 is equal to the square root of, oh, sorry, I asked for h, wasn't I? So let's just flip that, sorry about that. So h is equal to v0 squared g. There you go. So the question was, how did I get h equals d sine theta? Well, let's take a look at this. Take a look at that. H is equal to d sine theta? Because the sine of theta is h over d. So h is equal to d sine theta. Questions? Okay. And of course, this is saved online. Why did I cancel out v squared? Because this is final. In the equation, that's v final squared. And what's the final 0? Because it stops. Yeah, Iris? Shh, please.
The v0 over
when I subtracted V0 over, where? You mean here? Oh, I took this and put it on that side, that's why it's negative, that's negative, that's negative. No, and that's why, oh no, we're in trouble. Are we in trouble? No, because A is net theta. So you can see I just substituted in my negative G sine theta, and I went, hey look, I'm done. Oh, I'm not done. No solving for H. So actually what I should have done here, probably here, I should have solved for H instead of, I don't know why I solved for V0. Just brain fart. Okay. So that is all online.